Okay, so inside of this example, we're going to send a message from A to E, and then when E receives that message, it's going to do some work and then send a response back. Okay, so in our first example, there was no response, but let's say that the message that A is sending requires a response. So this is still going to be switch 1, and this is 2, but I'm going to label the specific port numbers over here. So this is going to be port 1, port 2, port 3, port 4. This is going to be port 5, port 6, and port 7. Okay, now these are just numbers that I came up with. The actual port numbers of devices are generated by the device manufacturer, and they might actually even have the same names. But that doesn't matter because this switch doesn't care about this switch and vice versa. Okay, but for simplicity of this problem, I'm going to use P1 to P7, each one representing a physical plug that is connecting a computer or another switch in this case. So again, this time A is going to be sending a message. The source is going to be A. Destination is going to be E in this case. And then when E receives that message, after it receives that message, it's going to send a response. Okay, it's going to send a response. The source is going to be E, and the destination is going to be A. So we'll start off with this first message. Okay, so this message arrives on port 1 to switch 1. Okay, so the first step that the switch is going to do, sort of the first step of the algorithm, is that it records the source address and the port number. The port number is P1, and the source MAC address is A's. Okay, and then it's going to check to see if this destination address is known. Okay, it's going to look it up inside of its table. If it finds it, it's going to deliver it to the port address associated with it. If it doesn't find it, it floods the network. So it doesn't find it in this case, it floods the network. So this message, A to E, gets flooded. To B, it's discarded. To C, it's discarded. To switch 2, okay? Switch 2, new incoming message, okay? So it's going to record this data, okay? Because it's a new, for any new incoming message, including duplicated ones, it can't tell the difference, okay? So this is very important. It can't tell the difference if this was originally from a computer or it was duplicated. Okay, so this one was duplicated by this one and sent out. And so it's arriving on port 5, and it looks at the source MAC address. This is from A. Okay, so it's going to record that. And again, it looks it up. It looks up this message. Do I know where E is? Okay, do I know where E is? And the answer is no. Okay, so it doesn't know where E is. And so it's also going to flood on everything except the one that it came back on. This is important because if you flood backwards, then you create a loop. Okay, so make sure you don't create a loop. So don't flood back on the way you came from. So I flood on P6 and P7, and then this one is discarded. Okay, and then this arrives at the correct location. Okay, so if this was the normal transmission, it would be done. Okay, remember, there's no automatic response. Okay, but it's very common to have a computer that will respond. Okay, usually communication is two-way. Okay, so if there is a response, it would look something like this. Okay, the source is E, destination is A, and then this message gets sent out. Okay, again, first step, P7 gets associated with E. Okay, because that's a new incoming message. Okay, now do I know where I'm trying to get to A? Okay, I'm trying to send a message to A. So the first step is I'm going to look it up. Okay, oh, A is associated with port 5. Okay, so I'm not going to flood because I found where this message should go. Okay, it should go to P5. So it should go out this way, okay, to this switch. Now, this switch gets that message. It's going to inspect it again. And what's the first thing it's going to do? Okay, so this message arrives on P4. And then we record P4, okay, is associated with E. Okay, so P4 is now associated with E. Okay, so again, what happened was this message over here was sent out from E to the to switch 2 on P7. Okay, it arrives on P7. So I record P7 associated with computer E. And then, because I know that machine A is associated with port 5, and I'm trying to get to machine A, it sends it out on port 5, which is received on this switch's port 4, which then will say, okay, let me inspect the source address. The source address is E, so I'm going to add a record. If I want to reach machine E from now on, I can send it out on port 4. Okay, so this is how the switch is learning, meaning that if later on machine B sends a message to E, okay, if later on machine B sends a message to E, then this switch knows that, oh, to get to machine E, go to port 4, and then it sends it to this switch, okay, and then this switch will say, oh, to get to machine E, go to port 7. Okay, this is how it's learning about devices. It learns about devices when messages comes in, when it checks the source. So finally, this switch over here, we'll see that this destination is A. I'm going to look it up. Okay, A is associated with P1. So I'm going to go send this message to P1. And then that completes the delivery. Okay, so now let's add your request, which was D wants to send a message to A. Okay, so let's do this one in green. Okay, so source is from D, and destination is A. Okay, so D sends a message to this switch. Okay, and again, the first step that the switch does is it records the source. Okay, so D is going to be associated with port 6. Okay, because that's where the electricity is coming in from. Okay, and then it's going to say that, oh, you're trying to get to A. I know where A is. A is, if I want to get to A, I'm going to send it out on port 5. Okay, so I'm going to send it out on port 5. Notice it doesn't need to flood because I know where A is from all my previous sort of work. Okay, then this switch also receives this message. It looks at it. This is the duplicated message. Okay, so again, step 1, record the MAC address and the port associated with it. And this is where it's interesting. Look, you have 2 port numbers associated with different MAC addresses. Okay? But this makes sense because if A wants to send a message to either D or to E, it has to go through port 4. Okay? So we can have duplicates, okay? It's just that when we get to switch 2 will figure out, okay, here is the specific. It's like you can think about this as like turn left on this street, and then this one is like, okay, you arrived here. It's the first house, it's the second house. This is telling you specifically turn left, and then first house on your left, second house on your left. So you can have the same port numbers over here associated with different MAC addresses, right? And then once we get here, that it knows where A is, and it'll send it.